Hello guys, my name is Engineer. I want to solve question on or talk about the analysis of lift and connected bodies, but I don't want to waste too much time in this class. So I'll be majoring on the shortcut and other things that will make the work faster. Now, in this case, we are going to look at lift or elevator analysis. Then we are going to look at connected bodies. But in this connected bodies, there's a condition. In this chapter, we're going to consider smooth surface. Smooth surface. So I want to listen and you enjoy it. Now, in a lift or in an elevator, there is what we call T here, tension, or what we call the apparent. This is called apparent what? Weight. So this apparent what? Weight. Now, this is what we call the real weight. Real weight. So this one is the real weight, this apparent weight. So this is what the spring balance we measure. We know that spring balance is used to measure force. So now what do we now do? Now since we know that this is apparent weight, now if the lift is stationary, that means it's not moving. The lift is moving with a uniform velocity. When you say uniform velocity, it's a language or term that means the body is at rest or is stationary or moving with an acceleration of 0. So what we're going to do now is that it's not going either up or down. We said what the tension equal to weight and equal to what? Mg. That means at rest, stationary. That is case 1. Now stationary. Case 2 is when let's say the lift is going up. If the lift is going up, it becomes what? C. If the lift is going up, that means upward tension now. Will now be what? That means favoring what? Tension. Weight is assumed to be smaller than tension. So minus mg, which is equal to ma, which is net force, mass times acceleration. This is net force. T up minus T down, minus weight down. That means weight up minus weight down, because it's favoring is going upward. So in this case now, if you want to make this one subject to formula, we can write as T up is equal to what? Mg plus what? Ma. That is upward. When the tension is going up, lift is going upward, what will the spring balance measure? The spring balance will measure the real weight plus net force. The next one is when the lift is going downward. It favors weight now. And if you do downward tension there, it's what? It's equal to what? Mg minus what? Ma. That is to say, when the lift is going downward, it is minus. When it's going upward, it's plus. That means this one, this A, is upward acceleration. Why this one is what? Downward acceleration. Downward acceleration. Upward acceleration, downward acceleration. What about if the lift fall freely? That means fall freely means the lift has an apparent weight of what? 0. That means if you don't have a mass, that means nobody is what? There's no object inside the lift. 2, the scale palm of the spring balance must be negligible, the mass of the scale palm. So the spring balance will measure a tension or apparent weight of 0. I told you T is what? The apparent weight. I told you what? Weight, W is equal to what? The real weight, which is mass of the object times acceleration due to gravity. This one is for free fall or a massless object inside the lift. That means it does not have a mass. There's no mass in the what? No body, no object of mass. M is inside the lift. So if 0 mass in the lift, and if you have 0 times what? G is 0. 0 times E is 0. So you give us 0. So, but in a language that you can also understand, physics language, we say the lift is falling freely. Fall freely. Now go and check my video on vertical motion. You understand what they mean by free fall. Now let's go to the next one, which is what? 2 blocks of mass M1 and M2 connected to a light stream passing over a smooth pulley. Now, this pulley is what? Smooth. It's a smooth pulley. So in that is what will be the common acceleration. Let's assume that M2 is greater than M1. Now M2 is greater than M1. Now the shortcut I want to give you is this one. A is equal to what? M2 sine theta 2 minus M1 sine theta 1 all divided by what? M1 plus M2 times G. This is the shortcut I want to use to find the common acceleration. So I want to find common acceleration now. Now what am I going to do? I'm going to what? Any object moving upward, look at it, upward or downward, I will take it as 90. Any object, any block that is sliding upward or downward will be taken as what? 90 degree. So what angle will this one move? It will be sliding at 90. What this one will be sliding at 90. So if you put 90 here now, sine 90 is what? M2. What is what? Sine 90 for theta 2. This is theta 1. This is theta 2. Sine 90 is also what? 1, which is what? M1. All divided by M1 plus M2 times G. This is common acceleration. And it's always positive. Please take note of that. The next one is tension. The tension in the string. We use what? M1, M2 times G into what? Sine theta 1 plus sine theta 2 all over M1 plus M2. That is the formula I'm going to use to solve it. Now the tension in the string is T. Is the common acceleration formula that we have gotten. So the tension in the string now, we'll use this one. Now what is theta 1? Sliding upward. To be anyone that once it's sliding upward, this lift, movement of the block up and down is taken at 90. While movement along the what? Sliding or forward or backward horizontally is theta equal to 0. So since these two are sliding up with what? Down. If this one is going down, this one is going up because this one is heavier than this. So the common acceleration move in this manner. Because we say M2 is greater than M1. So this is heavier block. Goes down, this one go up. So sliding down, moving up. So that's why we take it at 90, 90. As sine 90 is 1, sine 90 is 1. So 1 times M1 is M1. 1 times M2 is what? M2. So get our what? M2 minus M1 times G over M1 plus M2. This is the formula we want to use for what? For finding tension. The tension, this tension now, how do we find it? Use this formula. Now this formula is only applicable to what? To smooth surface. We have smooth pulley. Now what is sine 90 here? 1. Sine 90 here is also 1. 1 plus 1 is what? 2. So I would have 2 M1 M2 times G all over M1 plus what? M2 is the tension. Is the tension now. But the last thing I want to talk about there is what? Force. What is the force in this pulley? The force in this pulley, this smooth pulley. How do you calculate the force? We look at the two tension. Are they not moving upward? Look at the direction of the tension. Look at it. What is that? The direction of the tension, they are moving upward. So since they are moving upward, it is, if two vectors are moving up in the same direction, what do? You add them. So the force in the pulley system is now be what? Equal to what? 2T. Because it's now be what? The T plus T add together give us 2T. Now let's move to the what? Number 3. You understand? Don't forget upward lift, stationary lift. So if they ask you at what point will the apparent weight equal to the real weight? When the lift is moving with a uniform velocity, or when the lift is at rest, or when the lift is stationary, or when the lift is just about to move. Say what? It's at equilibrium. So that is it. This one is when the lift is what? Going down, is up, is down. And this one is what? When the lift is what? When the spring balance measure T of 0, it means the lift is falling freely. Now let's go to the next one. Now this one, we have a block on the smooth table, as you can see in the diagram, connected by a light string to a body at the what? At one edge. At one edge of the table. So this one is hanging freely. Free hanging. Hanging freely. Now we are still going to use this formula. Please go with me. Now I told you anyone that is sliding horizontally is taken as 0, either forward or backward. Anyone is sliding vertically, take it as what? As 90. So this one, let's say theta 1 is 0 degree. Theta 2 is what? 90 degree. So in that case now, if it's sliding what? Vertically, we take what? 90. So let's put it there. Let's go. Theta 1 is what? Is 0. So sine 0 is what? 0. Then theta 2 is 90. Sine 90 is what? 1. So 1 times m2 gives m2. So I'm going to have what? A will now be equal to m2 minus what? 0, which is what? No need to write this, times g over m1 plus m2. That's what I want to have as common acceleration. What about the tension? How do you get the tension? We don't need to suffer ourselves because the formula is already available. Theta 1 is 0, sine 0 is 0, plus sine 90 is 1. 1 plus 0 is what? 1. So 1 multiplied by everything here will give us what? M1, M2 times G over what? M1 plus what? M2. That is what? The tension in the string. Tension in the string. And this one is what? The common acceleration. Common what? Acceleration. Now, the next one is force in this pulley. Now, force in this pulley. Now, there is a tension here. Let's call it T. And there's a tension here. This tension is going like this, so it's going like this. Now, this tension, if you look at them, they are at right angle to each other. One is like this, the other one is like this. So if you use Pythagoras theorem to find the what? Force in the pulley here, this force in this pulley is what? It should be going like this now. So that force is actually, if you draw the diagram now, that means you would draw a parallel one to this one, going like this. This is the force in the pulley, F. And for us to find the force in the pulley, that means I've redrawn the diagram like this now, which is this one. For us to find it using Pythagoras theorem, here this one is T, here is T, horizontal is also T. To find the resultant, that means F will now give us what? It will be equal to what? C root 2. You know how to find it. F squared, use F squared equal to T squared plus T squared. This is what we are going to have. You have to work. If you have your pen with you, just do the evaluation. Make F the subject of formula from your what you call for that formula from Pythagoras theorem. You get the answer. So this what is formula of force in pulley. Now these are the three things they will ask you: the common acceleration, the tension, which is this one. If they will not ask you, I will not tell you. So I'm telling you because you will need it for this particular topic. You need it. Is what? In physics, we make emphasis on formulas. You understand? And that is the emphasis I just laid. Now, number 4. This one is a block on the inclined plane connected by a light string at the top of a mass hanging freely. So this mass is hanging under what? Under the influence of gravity, rather. There is a tension here. There's a tension here. So in this case now, what we're going to do is still use our formula. You see this, how this is helping us now. Now put what this one is at an angle theta already, theta 1. Why this one is was sliding vertically, so it is 90 now. So 90 degree already. So just put it in this formula now. What do you have? I want to have what? A is equal to what? Basically what? We put what? 90F. This is theta 2 for M2. So 90 sine 90 is 1. Look at it. Sine 90 is 1. So M2 minus what is sine theta 1? Okay, you can leave it like that. M1 sine theta 1 divided by what? M1 plus M2 times what? G. Now there is also what the common question they will ask you. The last one I want to talk about, I will only give two, is tension. Tension there, how do you find tension? You use this formula. The product of the mass times G, open bracket. What is sine theta 1? Sine theta 1 is theta 1 now. Sine theta 1, so we have sine theta 1 plus, because there will be, then plus, well, what is our theta 2? 90. So sine 90 is what? Is what? 1. All divided by what? M1 plus M2. But there's something I want to talk about here. Now, don't forget that let's call this one A and let's call this one B. From A to B is what we call the length of the inclined plane. While here is the height. From here, the height of the inclined plane, H. Now, if you know that that is your length and height, length of the plane, height of the plane, you know that to find this theta be very easy. Sometimes they don't give us this theta 1. So sine theta 1 is equal to what? Opposite over what? Over hypotenuse. Remember your SOHCAHTOA. So that means that opposite is your H, height of the what? Over length of the inclined plane. So automatically means that I can replace what? Sine theta 1 with what? H over L in this formula. So in place of this one, I can just put H over L. If you now see maybe in question H in L, that is a language of opposite over what? They can say 1 in 60. They can say 3 in 65. It means that 3 is height, 65 is the length. So 3 over 65 will now be replacing sine theta. Because some of you now will be expecting the examiner to give you theta 1. And most of the time, they don't give it. They don't give those values, theta 1. They don't give the angle. What they will just give you is that they will provide you with height, then provide you with the length of the inclined plane, which that is enough. That is enough for a good student that knows what he or she is doing. So number 5, the last one. Low and below, ladies and gentlemen, number 5 is just represent A, the way it is, and T, the way it is. I mean T, this formula. So our last one is common acceleration. M2 sine theta 2 minus M1 sine theta 1 all divided by what? M1 plus M2 all bracket times G. So if I want to find the tension also, as a product M1 M2 times G, the formula being sine theta 1 plus sine theta 2 all bracket times what? Okay, all divided by what? M1 plus M2. So this is the what? The tension and the common acceleration that you can be asked for connected bodies. But what I want to do now is that I want to go into the last part, which is the what? The 3 bodies on the what? On the table. We have one placed on the table. Then the 2 masses are now hanging freely. So what we are going to do now, that's what we are looking at now. The 2 masses hanging freely. Now, in this case, now we have M landing and connected to what? 2 masses. M1, or let's say M2, and this one is connected to what? M1. Now, how do we calculate the common acceleration? The common acceleration. The common acceleration, we still use this formula. We use the formula. Let me check my mic. We use the formula now. So this one now will not be what? If you are using this formula now, but you know that this one is gliding horizontally, so theta equal to 0. So it will not be involved at the numerator. This one now is heavier. You say M2 is greater than M1. Then this is a block. This one is smooth surface. So 2 blocks are connected to a glider hanging freely. So in that case now, what we are trying to do now is to calculate the common acceleration. Now, the common acceleration will not be what? This will not be, theta 2 will not be 90. Theta 1 is what? 90. while this one is 0 degree. So in that case, this one will not be involved. So this one will not be what? M2, because M2 is greater than minus M1, if you use this formula, over the sum of their masses, M1 plus M2 plus M. Now what is, we must multiply times G, times G. Now what is the difference between this one? No? Yes? What is the difference between this one and this one? That's how I'm not clearing it. If you notice that there is what? Addition of what? Just the grinder. Mass of the grinder. Finish. Then what about the tension? The tension will not be what? Different. No? Now, we are going to have two tension here because we have two pulley. How? There's one pulley here. Let's call it T1. Sorry. And this is T2. Now, to find two tension, we are going to calculate two tension. To find the two tension, one is moving downward, one is moving upward. Listen, the one that is moving upward is one that is light. For example, this mass is heavy. This is 10 kg, this is 5 kg. Look at the board. This one will what? Look at it. As this one is sliding like this one will what? Go like this. So as that process is occurring, this one is going downward. What is downward tension? T2. Downward tension is equal to what? M what? 2G minus M2A. Now using that what? Downward lift. The lift, that formula I gave you for lift, when a lift is going downward. Then this one, to calculate T1, here, you are going to use M1G because it's moving upward. Use lift going upward, M1A. But the problem student we have is that what is my A? That is not a problem. If that is a problem, that's not a problem. The A is what? Is equal to the common acceleration. And don't worry, common acceleration can never be negative. Because it is not possible for you to be, maybe you want to tow a car that had a fault on the road or on the highway. And you now begin to what? After tying the string to the car to enable movement in forward direction. Meaning that somebody will be inside to what? At least to aid the move direction, to be able to have a specific direction. And to also, it is not possible for you to be reversing or to be decelerating while towing that car. If not, the person at the back will be uncomfortable and probably cause accidents. So you don't decelerate during common acceleration, during connected bodies. Rather, you continue to accelerate. So A is always positive. So this tension is there. So for you to find tension now, we are going to have this body, this system we have, what is over 6. We have two systems, two tension rather, because you have two pulley. Number one tension is this. And number two tension is this. So another thing again you're going to have is two forces. You're going to have force in the pulley. Two. What are the force in pulley now? The force in pulley for this one. You will now use this one. Hello. Let me divide this into two for you. Let me do something so that you can see clearly. If I divide this into two like this, look at it. Do you know you are seeing something here? Look at it. It's not, you are seeing one part of this one, and one part of this one here. That means you are seeing two of this one, kind of. If I divide it, look at what I'm saying. Divide this one into two. This particular system divided into two. You are going to have this kind two for two different pulley. So if I want to use the formula to calculate force in the pulley, I will use this one. To calculate force in the pulley, I will use T2 with 2 for this. Then for this one, I will use T1 equal to what? F1. The force in the pulley of this one is F1. The force in the pulley of this one, F2. I will now have what? T1 with what? 2. So this is what? No, this is second force. And that will end our what? We have calculated the common acceleration. The tensions in the pulley, tensions, I use tension plural because they are more than one. Then the forces in the pulley, because there are two pulley here. The force 2, force 1. This one is what? Downward. That's why I use minus. Because M2 is bigger than M1. This one is upward. That I use plus. So in that case, this formula will be used in my next video to solve with problems. And if you want to now, I will do a derivation of, for those of you that want to know how this formula comes about, I will do connected body of a friction surface. This is connected body of a what? Of a frictionless surface. So I will do connected body of a friction surface. From there, I will now link it up with frictionless surface. I will show you how the formula can be gotten by derivation. Because some of us are not satisfied with all this shortcut. We want to see the reality of the formula by proper derivation of these formulas for enabling to enable you to remember this formula properly. But nevertheless, I believe I've been able to do what I'm supposed to do in this channel. Thank you very much for this topic. God bless you. Make sure you like and subscribe. If you are a new world, you are just seeing my video for the first time, or probably you are a returning viewer, thank you for watching my video, and make sure you like and share. Thank you. God bless you.